So here's a few examples of what we can do with properties of quadratic functions as long as we know our forms and our function is in the vertex form. So let's take a look at this first example. F of x equals negative 3 times x minus 2 squared plus 3. So right, we know this is in vertex form, and we can know that our vertex is going to be just going to be 2 and 3. So what we could do is we could sketch it really fast. Now we know it's going to be shaped like an N because this is negative, so it's going to be open down. So we can actually tell that also. It's going to be shaped like an N. And then we can sketch it, just a rough sketch. And the vertex is going to be 2, 3. So I drew a axis over here, and I'm going to go out 2 up 3. So that's my vertex. And know it's going to go down like this. And it keeps going forever. So what we know is that it's going to have 2 zeros, or 2 x-intercepts, or 2 roots. So we can look at this and we can say we have 2 x-intercepts. Sorry about that. 2 x-intercepts, or 2 zeros, because that's where the value of the function is equal to 0. All right? So it's going to cross there. We also know, because it has 2, that our discriminant, b squared minus 4ac, must be greater than 0, because we've got 2 roots. Now the axis of symmetry, we can find that out. That's the axis that the parabola is symmetrical to. In other words, the left side and the right side look the same. This is our vertex, which was 2, 3. And the axis of symmetry is just this x equals 2. And it's a straight line, a vertical line. This is y. Now, if it's going up like this, it does have a maximum value. The maximum value is y equals 3. That's as high as it goes. It has no minimum because it keeps going down and down forever. All right, so we can tell all that just by looking at our equation. Then we can also tell the domain. The domain, and for all these parabolas, it's going to be the same. It's going to be negative infinity to infinity because they just go on and on forever. But the range, I'm going to go from negative infinity. I'm going to go all the way up to 3. At 3, then it goes back down. So it's going to be negative infinity to 3, but a bracket at 3 because it's equal to 3. Okay? Here's another example. Let's take a look at this one. And again, first thing we do is it's positive, so we know it's shaped like a U. And we look at the vertex, and the vertex is going to be negative 4, its opposite sign, negative 4, 1. So I can draw a quick sketch. Negative 4, 1, there's the vertex, and it's shaped like a U, so it's going to look something like this. So does it have any intercepts? No. So it has no x-intercepts, no x-intercepts, and therefore no zeros, because the x-intercepts are the zeros, so it has no zeros. So therefore we know that the discriminant b squared minus 4ac must be less than 0 if we have got complex imaginary roots. And the axis of symmetry, we could figure that out. This is the vertex, and that's the point negative 4, 1. So this is x, this is y, so the axis of symmetry is just the line x equals negative 4. And does it have a maximum or minimum? Looks like it's got a minimum value. Well, I guess I forgot to write up here we had a max. This is the min. This is the axis of symmetry. And this is the max value. And here we're going to have a minimum value. And that's going to be y equals 1. That's the lowest it's going to go. It's going to go back up. So everything's going to be greater, so that's going to be the minimum value. So you can tell all this stuff from here. Now what's the domain? Well, again, the domain is going to be the same. Negative infinity to infinity. That means the x values, because these keep going out. It's hard to tell, but they keep going out, up and out forever. And then the range of the y values. And that's going to start at 1. It's going to be equal to 1. It's going to go all the way up to infinity because it's going to keep going. So if we look at these two again, guess I got down over there. So again, you just get your graph over here, and your vertex is negative 4, 1, so you can see that our axis of symmetry is at x equals negative 4, that's this vertical line, and the minimum value is y equals 1. It doesn't cross the axis, so it has no intercepts, no zeros, so we know that the discriminant must be less than 0. Since this is positive, we know it's shaped like a U, where there's our vertex, and we know our domain, all real numbers for the x, because these keep going out and out, and the range goes from 1 to infinity. All right? So you can tell all that stuff if it's in vertex form, so you can know a lot of things about these. So here's a couple good examples of all these properties of parabolas.